Good to see you folks again. One update. Last time we were together, a student had helpfully raised a question about the issue of aspect J on the Sphinx machines. And as promised, I looked into this more with the recognition that if there were some persistent issue there, I'd have to make that part of the problem set, the assignment optional, shift the marks elsewhere. The good news is that, so the bad news is that it used to be installed as a regular basis for classes, and apparently they've kind of deprecated it for this year, but based on my request, they've put it back on Tux World right now. So if you folks, are you folks familiar with Tux World for remote login? So Aspect J is on there, and you can log in. I'm going to be logging in to try using it just to make sure the whole installation is fine. And once they hear back from me on that, they're going to put it out to the entire lab. Okay, so I'm just so grateful for you bringing it up. Was it Peter? Is that right? Who brought that up? Great, you did. And as far as I understand, it should be out to the lab very quickly after I request it. So I'd expect no later than tomorrow. Please let me know if you encounter any ongoing problems with it. But as of right now, you should be able to log into Tux World and use it on Tux World. So if you want to pursue that part of the assignment, you could do so right now in Tux World and by tomorrow across the entire lab. Of course, some of you may have installed it on other machines to which you have access, maybe your own, and that's also, of course, fine. So that's the Aspect J availability issue. Okay, so for this class, with an eye towards preparing you for two final take-home exercises that are going to expose you to aspects of Scala that we've been talking about, I wanted to expand on one issue that we talked about last time, or two variants of that issue, and then I wanted to hit on a big topic as well, which is the use of what are called traits. And these are for a topic we saw a number of weeks ago called mix-ins, where you can take implementations and mix them in with a class from many classes, not just from one. So rather than having inheritance, which in Java and Scala is limited to come from a single class, we'll have a way of mixing in functionality from many, many classes. Okay, so we'll link back to some issues we talked about with subclassing. But first, ladies and gentlemen, I felt I didn't do full enough justice last time to one issue having to do with Scala, and that's this issue of how these sort of matches are carried out. So we saw last time we had this match operator, and the match operator in Scala, ladies and gentlemen, can be used in a kind of classic way, like in many C languages, C, C++, Java, where we have, case 1, 2, 3, these are constants. But it can also be used to match values, which are then bound. That is, if it doesn't match 1, 2, or 3, or one of these other cases above case n, then it will match, if n is an integer, or excuse me, if the value being switched on, being matched, is an integer, it will bind n to it and let you then refer to n as a sort of general integer. So you can have code here that includes n. So that was one aspect of, and then we saw how we could, with the same operator, this match operator, we could have, for example, matches to different cases based on a predicate. We could say x if it's even, or n if it's prime, or n if it's a square. And we saw that we could have, well, actually, I didn't have this last time. We're going to come back to that, but basically we can do it with regular expressions and match pieces of regular expressions. And we can match different types here, okay? And we saw how we could take a big num, and using this sort of fancy mod operator, we could take its quotient and remainder and bind those as variables, which are then referred to over here. And here, if we have a value that is potentially empty, but otherwise held some value, in other words, it's an option in Scala, we could match it like this. And v, if it's a sum, if it actually has a value in it, we can match v to that value and then use that value. We've extracted it. And we call these things extractors. These things here indicate aspects of extractors. So they're extracting these values from whatever is being matched up here. So we have some expression up here, we match it, and we extract values. We match this expression, we extract a value from it. We match this expression, we test it, and we've extracted, in this case, it's just whatever is being matched, x. Okay, so there are these extractors. And we're going to come back and see how these extractors can be used to extract pieces from a regular expression. So we can have a regular expression that matches a string, and the pieces of the regular expression, each successive match, can be extracted and then used. So this essentially matches day, month, and year to each of the components of this regular expression, each of these so-called groups, which are in parentheses. And a long time ago, you folks may have heard me introduce regular expressions in 214, and we talked about these groups matching, sort of delineating these areas of the regular expression that are of particular interest, and this allows you to easily extract each of them and refer to them. So what I wanted to just talk about, because I felt I didn't give it enough attention last time, was how these matches are done. How do we, for example, with an array, extract the values of the array? How is that accomplished? How do we take the list apart and match it to different cases here? Well, it turns out that the way we do it in Scala, as a nod to the many nice features of the language, this is one of them, it's through a mechanism that you can define, that's definable by you folks, and it's called the Unapply operator. And this is just a method you write. You write Unapply for a class, and it can then allow you to perform this sort of extraction, this sort of extraction, this sort of extraction. So I want to talk about it. How does this Unapply operator work? Okay, so the thing that's really confusing about this is that we use the Unapply operator in a way that binds values, like day, month, and year. But the way those are phrased, the way they're framed, the way they're written, it almost looks like these are parameters. It almost looks like these are arguments to pattern. It almost looks like x and y are arguments to an array, where we build an array. And you have to get beyond that initial appearance. That's just how it's sort of shown. But they're actually not. They're not arguments to it in a traditional sense of the word. From a certain perspective, it makes sense that they're shown that way. Because, ladies and gentlemen, in Scala, when we have something like array of x and y, the way this is supported, if outside of a match, we write array of x and y. Let's say array of 1 and 2. Does anyone remember what that does? If I say array of 1 and 2, what does that do? What does that give me back? Gives me back begins with an A, an array. Good. Holding the values in 1 and 2. That's what it does. That's its job in life, is to do that. And if I have array x and y, it'll build an array of x and y, the two elements. And if I have something which has 1, 2, 3, 4, it'll build an array of 1, 2, 3, 4. Okay. Now, and you know, ad infinitum. Now, the way this is supported, ladies and gentlemen, the way this is supported is as an apply operator. It's called apply. We're talking about apply now. We're going to get to unapply in just a moment. But I'm trying to make sense of unapply by reference to apply. Okay, so if I have apply of, and just to keep this kind of consistent, if I have apply of x and y, I give it x and y, and I get back an array. Okay, this is an apply operator actually in the, not in the class array, but it's in the companion class for it, the object array, it's called, object array, which is where you put things that are static. That this is not being called on a particular array, it's building an array. And the way we do that is we have an object array singleton, and we define an def array in it, okay? And that can basically build an array here. And then we don't have to say new array, we just say array. And it builds it, because it's applying this thing as if it's a function. Whatever this thing is, we just call it as if it's a function. So the job in life of apply is to take the pieces of the thing and build the whole thing out of them, right? This takes x and y, and it builds an array holding x and y. You appreciate that? I'm not asking, do you like it? I'm asking, do you understand it? Hopefully no one horribly dislikes it either. I actually think it's pretty neat. Okay, you folks might say pretty cool or pretty sweet. I think it's both of those too. Okay? Okay, so this is the apply operator. It takes the pieces, x and y, and it builds the whole thing out of them. Does that make sense? And we do it by calling something like array x and y, and give it the pieces, x and y, and it will build the whole thing. That's the apply operator, apply. Now, what does unapply do? Well, I'm trying to make sense of this notation. What it does is take the whole thing, the array, and extracts the pieces. So this takes the whole array and matches it in it, extracts the pieces of it, x and y. That's what you get out, is the pieces. That's what you took in for apply, and you got out an array. For unapply, you're going to be given the array. Take that in, and what are you going to get out of it? What good things are going to come out of it? The pieces, x and y, which you can then use. Right? So the advantage of doing this is that now over here on the right-hand side, we can use x and y. They're bound. They are extracted. So here we can use v, right? Because we've bound it. We've taken the option apart, and we've extracted v, and we can use it. Does that make sense? We've taken the array apart, and now we can use x and y. Not that the array disappears. We just extracted x and y from it. We extract quotient and remainder from the result of this kind of fancy mod, right? We've extracted day, month, and year from this regular expression from the string by matching a regular expression. This regular expression, we've extracted this one here. We've extracted day, month, and year. It gives those back to us. So apply goes from the pieces to the whole, and unapply is going to go from the whole to allow you to get the pieces out. Does that make sense? Okay, it's a funky notation. I personally have misgivings about this, because this looks all the world like they are being passed into pattern. They ain't. They're being extracted from this thing being matched through this regular expression called pattern, okay, which is regular expression. See this dot r? It's a regular expression. It's not a string. You might have missed that. This is a dot r, which means it's a regular expression. We'll come back to that. Okay, so ladies and gentlemen, unapply kind of reverses apply. Apply takes the pieces out of which the string should be made, and it creates a whole string. Unapply takes the apply takes the pieces, it gives you the whole thing, and unapply takes the whole thing, gives you the pieces, lets you bind to the pieces. Okay, so what does the unapply operator take in? How do you declare it? Well, it takes in a value to be decomposed, okay? Takes in a value that needs to be taken apart. And having done that, it returns back a value that indicates, was it successful, and if so, what are the extracted values? Okay? What are the extracted values for it? Okay? So unapply is going to typically return. So we might, for example, have unapply for a regular expression. You know, class regular expression, I'll just call it. And the unapply here is going to take in what we're giving it in this match. So here, it is going to take in a what? For the regular expression, unapply is going to take in the string. Okay, it's going to take in a string. And it's going to return, ladies and gentlemen, a sum. Okay, it's going to return. Well, excuse me. Technically, it's going to return an option of type, and it's going to be, I'm going to say array. It may be another collection. Okay, an array of strings. Okay, and so it's an optional value. It might hold nothing, or it might be an array. Okay, so unapply here, we're taking a string. Let's take in this guy here, and it's returning back these things. Day, month, and year are the strings that are within this array, and this will match the case where it's day, month, and year. Each of these are successive elements of this array. It might return a tuple. I can't remember off the top of the head with this. Or alternatively, if we had a class associated with this, we might have a tuple, and the tuple class tuple. If we had unapply here, it would take in, okay, I've got to be careful here, right, so unapply here is going to take in a tuple. That's the thing returned, say, by this operator here. So it's going to take in a tuple. It's going to be a 3 tuple, and I think it's called tuple 3, something along like those lines. And it's going to, so I'm going to call it T tuple 3, and it's going to return back so it's going to return back sum. Okay, return back a tuple. Excuse me, this is tuple 2, and it's going to return back as well a tuple. Okay, so this is going to be tuple 2. So it's actually just returning the thing that it took. Excuse me, this is option. Okay, so here unapply, ladies and gentlemen, basically it takes in a value and it extracts the pieces of the value. So this took in a string here, and it extracted the pieces of the string as an array. And in this case, it actually takes in a tuple, returns a tuple, so that it doesn't even probably have to be defined. Let's talk about some other cases here. For an array, so if we had a class array, I'll just write it here, class array, we might have something like this, where unapply takes in an array, and I'm going to write this informally, an array of T, and it is going to return an option of some tuple, like a 2 tuple. Okay, so it's going to return something that might or might not hold a 2 tuple as one of the values of unarray, and that will handle this case, x and y. And then there might be another version of Unapply that returns a 3 tuple and another one that returns a 4 tuple, so it can match up these values. Okay, so the idea here is that Unapply is going to take in the entire thing and it's going to allow you to match these. And the way in which it does it is by returning, in most cases, an option value. If it's empty, it's considered non-matching, and if it has something, if it's a sum, S-O-M-E, then that's the value you match, and it will use that to bind each of these guys here. Okay. Now, there are times where instead we want something which is just going to, excuse me, where's my good example for that? Where we just want something which is going to return true or false. Okay, so we could even have a unapply operator that, for example, just tests the value that it gets and it doesn't bind to anything, in which case it could just return a Boolean. Okay, so let's take a look at how this works, okay? Again, Unapply indicates whether or not a match was made, and it does that by false. So if a match was not made, it indicates false, or it's empty option. If it matches, it's true. If it's a Boolean, or it has the option has some value in it, okay? And then secondly, the value that it returns, the sum, has several components that are then bound to name values in the code. Okay. These two values are interlinked. So let's take a look at this example we've seen before. So we have object twice. This is an object. This is a companion class. So it's a singleton twice. And notice there's an apply operator. Okay. So we could just write, instead of writing new twice, we could just write twice of some value. And here what you'll see is twice of 21, okay? And that value is going to return back, in this case, an integer, which is going to be, in this case, 42, twice times 21, okay? So apply here is going to take a value in, and it's going to return back a value that's sort of twice something. Okay, so it takes a value in and returns back this twice thing. Now, Unapply is going to take in any integer and it's going to test, is it even? And if so, it's going to return that value of which it's twice. Okay, so it's going to return z over 2. So if it gets an even value given to it, let's say 42, it's going to return 21. If it gets 2 given to it, it's going to return 1. But sum, and that sum is an option. Okay, it's an option of n, and that's going to indicate, if it's returning sum of z over 2, that indicates it did match. So it got in, let's say 42. It now returns an option value wrapping 21. Inside of it is 21, but it indicates, yes, I'm some value. And that will indicate that this case matches. Now, what will n be here? What will be the value of n? The value of n will be whatever is in this sum, which will be, if we give it 42, it'll be 21, and that will be the value of n. That's matched, okay? So here we have construction with apply of an x, which is going to hold, in this case, 42. And then we say x match, and here we have this case which extracts of what is it twice, right? Remember, apply takes a value, it gives you kind of the whole thing out of it, and the whole thing is the double of it here, and Unapply does the exact opposite. It tells you from what values that whole thing came. Of what value is this twice? And that's going to be bound to n. And where is it getting that from? It's getting it from this sum value return. On the other hand, if this match here is called on an x that's not even, this won't match. This will return none, which is kind of indicating an empty option, and it will fail. This match will fail. It will go on to look at other cases. So here, ladies and gentlemen, we have a very simple apply and unapply. Apply kind of maps general integers into even integers, and the twice unapply, this unapply of twice, gives any integer, it will return, if that integer is in the category of even integers, it will return the value of which it's twice. In other words, the half of it. Otherwise, it won't match. So this twice here is actually a call to unapply. Twice of n is calling unapply with an argument that's x, right? That's how match works. Match operator is going to successfully go through the cases, and if they involve something where unapply is needed, it's going to call unapply with whatever is being matched. Here it's x. And it's going to call unapply with it, and it's going to run unapply, and if it gets back a sum of something, it succeeds. If it gets back something that's none, it fails, and we'll go on to the next case. So in each of these, it's running unapply. Twice of n, it's running unapply. It's getting back, if it gets back a value sum of, say, 21, n is bound to it, and then we use n. So that's how unapply works. Unapply is kind of the opposite of apply. Here's apply, array of x and y, and unapply is going to take an array and give us x and y to extract. And how is it going to give us x and y? How is it going to get us x and y? It's the return value of unapply, the option. Now, it looks the opposite, doesn't it? It looks the opposite, ladies and gentlemen. It looks like these are the arguments to this thing. But no, those are the results of the unapply operator. Those are the return values of the unapply operator. And what's the argument to the unapply operator? What is it that's given to unapply? Well, for this case, what's given to unapply? Can anyone tell me? For this case, what is given to unapply? The string. For this case, what's given to unapply? The array, right? For this case, what's given to unapply? On what is unapply called? It's this thing here, right? That's why it almost seems backwards. I mean, these things here are the result of the return value of unapply. This thing here is what unapply takes as arguments. But the way it's written, you could be forgiven for thinking it's the opposite. Okay. So, for example, here we might have a case class, and then when we have a match, we say v match this. V is some value, and basically we say, okay, we call unapply on v, and we ask, is this an and spec? If so, it's going to return a tuple of left spec and right spec. And if it is, if it returns sum of a tuple, this will be bound to the first element, this will be bound to the second element, we're off to the races. If it returns empty, in other words, none, then we fall through. So case classes already contain an unapply method. And they contain an apply method. So we can just create one like this by calling it without saying new. Okay? They have a companion class that basically defines an apply operator that allows us to just build them like this. And in general, you can have many unapplies and you can have many applies. Different unapplies would give you, so for example, here we can see array has many unapplies. Some are for the case where it is just one element here. Some are for the case where there's two elements. It may provide many unapply operators, okay? So, and similarly, it may apply many apply operators. The companion class might have this one. It might have an apply operator that just takes a single argument, and it'll have one for 3, 4. Actually, we'll have it for variable number of arguments, which are really easy to do in Scala. Does that make sense for apply and unapply? It seems kind of backwards, but that's the syntax. Now, it turns out that it has some really nice features to it. And I'm not going to go into nested submatches because we don't have time. But I will show you one feature that's quite nice, okay? And I believe I have an example of this earlier that I've incorporated into the latest version of this. Okay. So where are my vals and vars? Okay. Here we go. Yeah. Okay. Yeah. Unfortunately, it looks like I don't have that. Here we go. Yeah. This is exactly it. Okay, ladies and gentlemen, this is another feature of how we can use these extractors. One place we see them is in match expressions. Another place we see them is in something like this. Val, this is a regular expression pattern, day, month, year, equals some string. What is going on there? Can anyone interpret that? So I'll tell you, Unapply is being called on the string. What are day, month, year, do you think? Those are, well, it's just like this guy. These are the values being extracted. These are the values being returned by Unapply. And basically what this is doing is it's trying to extract day, month, and year from a string. Okay? So in general, if we have something with an Unapply operator, we can use it in these contexts. So for example, we can say val array of x and y equals some array, okay? To extract values from a two array, okay? Now, this is counting on this array having 2 elements only. But these values will then be bound as variables, x and y. Just as, other times we could have said val x equals 2 and val y equals 3. That's one way to bind x and y, but another way is in this sort of syntax. Through Unapply. And it's the same basic pattern you see here, where we have a whole that is being decomposed into pieces, each of which we name. We can take apart values really easily in match statements, and we can take them apart in val statements, where we introduce a name, a nice name, in this case, day, month, year. We're introducing those names to refer to the pieces of the string. Okay? And notice we could do it as well in a for loop, for example. For example, we could look. So let's talk about regular expressions. I wanna introduce them here, and we'll talk about how they're a beautiful illustration of these features. So in Scala, it gives me great pleasure to tell you about how simple dealing with regular expressions are. So we can have a string, and normally we deal with what's called a raw string. Does anyone remember a raw string from last time? What's a raw string? Actually, from 2 times ago. Does anyone remember what a raw string is? What's raw about a raw string? Anyone remember? What happens normally if I have a string? So I'm going to have a string of Java. And I'm going to have this regular expression in a string in Java. So I'm going to have 0 to 9. And 0 to 9, and then I'll just have a piece of this. And I'll put this to indicate a dash If I don't, it'll try to interpret the dash, right? So I don't want that. And then maybe I want to follow it by something that's a \n, meaning a new line character, something like that. Okay. Suppose I have this, or say a tab character, \t. Suppose I do this in Java. What will happen when I give Java this string? What does it do? Well, one of the first things it does is Java will try to interpret these \/ characters. It's not going to let the regular expression machinery know about them. It's not going to let the regular expression machinery see this \. Instead, Java is going to try to interpret this as a \/ something. It's going to try to interpret \t and replace this by a tab character. And the regular expression is never going to see \t. If you want the regular expression to see it, if you want this thing to be used in regular expression as a regular expression, what do you have to do to prevent Java from turning \t into a tab? What do you need to do in Java? It's unfortunately a very common thing. You need to put another \, another \, and it looks horrible. I mean, my writing is bad enough, but to have that on top of it is adding insult to injury. Wouldn't you agree? Okay, so ladies and gentlemen, this is bad. This is not good. We don't like that. Okay, it's not so good. So Scala provides the option of having what are called raw strings. Okay, where basically this is not interpreted. Okay, and we can indicate them in Scala by putting triple quotes around things. So if we have triple quotes around this thing, basically it will leave alone. It won't interpret whatever's in this string. It will just give you exactly what you have there. So normally we use raw strings to encode regular expressions because they're chock-block full often of backslashes. Backslash this, backslash that, \1. We'll use that to indicate the first match or what have you. And so the chock-block full of those things, and we don't want it to interpret them. So if we have a raw string like that, or if we have any string for that matter, but normally we like raw strings, we put .r at the end. And that turns it into a regular expression. It says, hey, interpret this as a regular expression. Okay, so given a regular expression, okay, now we can do useful things with it. So if we have this regular expression, now we can ask, hey, find the first match in some string, okay, or find all matches. I should say not int, but in, in, not int. Sorry, in a. Oh man. Hey. Okay. This is not good. Okay. Or we can replace them. We could say, hey, replace the first one with another one. So here we're looking in one string and we're replacing cases where the regular expression has been found by this replacement. And this replacement can get substituted in to this string and return back another string. Okay? And replace all, replace first. So it's quite nice. But my attention here is how does this intersect with matching the groups? Well, it turns out that these things here in parentheses, what are those things? What does this denote? The fact that we have parentheses. Oh man, this is not even balanced. The fact that we have parentheses here. What does this parentheses denote? Does anyone know what that's called? These guys here. It's called begins with a G, ends with a P. It is an O in the middle. A group, indeed. It's a group. So if we put these parentheses around, it means it's a piece of significance. And we want it to kind of remember this piece, remember this piece, remember this piece, so that we can extract it. In this case, we might have, something like 2403, and this would be 16 or something. And we want to extract these successively as a day, month, year. Okay, so day, month, year, and they're separated by these hyphens, which are shown here, but they have to be backslash so that the regular expression doesn't turn them thinking that you're meaning a range. Okay, so it turns out that these pieces, this is the day, this is the month, this is the year, can be extracted. And the ways in which we extract this are even sweeter than these things. So basically what you'll say is, okay, if you have a regular expression, you can extract the day, month, and year like this from some string, okay? So day is going to correspond to this guy. Month will correspond to this lady. Year will correspond to that gal. Okay, so each of those is going to correspond to successive elements, successive groups here. And having extracted those, of course, then we could use day, month, year. All right? So strings, but we could render them into ints by turning them into ints. So, ladies and gentlemen, here we could bind them to a value, or we could have a match expression where we match them and we extract day, month, year. Okay? Or we can have a loop, which loops through each match in a string, gets the day, month, year associated with that, and then uses that, maybe prints it out to a file. Now, I emphasize this because in your take-home exercise for Thursday, which I will be posting today, you're going to be doing this for a file. Okay? You're going to be going through, you're going to look for two different types of matches, two different ways dates can be written, and handle each of them and print out a canonicalized, a kind of standardized set of dates coming out of that. You're going to read in a file, do this, and print out a kind of version of the file that's standardized for one way of specifying dates. And you'll want to use this pattern. You'll loop over each element, and you'll sort of replace it with day, month, year. Okay, and you'll be able to print it out accordingly because you've bound the day, month, and year out of this thing. I don't know about you, but I've worked with regular expressions in many languages, including some that support them in a very nice way, like Perl. But this is, and I've done a fair bit in Java with regular expressions. Done some, I think maybe even C regular expression libraries way back in the day. But this is about as good as it gets. I mean, this is really nice. You can just extract these pieces and use them with these regular expressions, and you can do it in matches, or you can do it in sort of variable declarations like that. Okay? Are we okay with that? Okay. So, regular expressions are your friends, okay? And if we go back to, hey, no, okay, don't do that. If we go back to this with regular expressions, okay, I thought I had a nice other case of a regular expression base. Yes, here we go. All right, so we have this regular expression. We match the string, and it extracts the pieces. And remember, what's going on under the covers is that Unapply is being called on the string, and it is returning day, month, and year that it gets back as the return value of Unapply, and that's how it can bind these things, day, month, year. And if it can't match, it says none, and it doesn't match that case. Make sense? Okay, ladies and gentlemen. So that was regular expressions, unapply, and apply, and match operators in Scala, and a bit on raw strings. Okay, and now we want to hit on the other big topic for the day. Okay, that was a good element, and now we're going to talk about traits. traits in Scala. And because this marks a transition of significance, because some of you might want to watch each separately, I'm just going to